वेलकम स्टूडेंट्स, हम डिस्कस कर रहे हैं दी सेवेंथ न्यूमेरिकल फ्रॉम द एक्सरसाइज फॉर द चैप्टर मैकेनिकल प्रॉपर्टीज ऑफ सॉलिड। सो लेट्स स्टार्ट। सबसे पहले हम डिस्कस करेंगे क्वेश्चन। सो लेट्स टेक अ लुक। सो क्वेश्चन में बताया है अ वायर ऑफ मटेरियल माइल्ड स्टील। सो माइल्ड स्टील से हमारा वायर बना है, हैज इनिशियल लेंथ 1.5 meters and diameter is 0.60 millimeters. This wire is extended by 6.3 millimeters when a certain force is applied on it. हमें पता है जब भी किसी वायर पे कोई फोर्स लगता है, so it undergoes deformation and this deformation or extension is given to us. Now, if the Young's modulus for the material mild steel is 2.1 into 10 raised to 11 Newton meter square, then calculate the force applied on the wire. इनिशियल रीडिंग से एक चीज क्लियर है, फोर्स कैलकुलेट करना है, द फोर्स विच इज रिस्पॉन्सिबल फॉर दिस एक्सटेंशन. So let us now try to understand what sort of quantities are given so that we can calculate this force. First statement में first quantity is given to us, that is the length of the wire, and that length is given to us as 1.5 meters. Meters SI unit, no need for conversion. Second quantities उसी के बाजू में दिया है, that is the diameter of the wire. So उसको हम represent करेंगे using the symbol small d. This diameter is 0.60 millimeters, which we convert it into meters, then it becomes 6.03 into 10 raised to minus 3 meters, as 10 raised to minus 3 millimeters is 1 meters. इसके बाद सेकेंड क्वांटिटी जो हमें दिया है, थर्ड क्वांटिटी सॉरी जो हमें दिया है, दैट इज द एक्सटेंशन. सो एक्सटेंशन बोलो या चेंज इन लेंथ बोलो या इलोंगेशन बोलो, it is all represented by the same quantity, that is delta L, that is the change in the length, and this change in length is given to us as 6.3 millimeters. Again, millimeters needs to be converted into meters, so 6.3 into 10 raised to minus 3 meters here as well. And then the fourth quantity जो दिया है, that is the value for the Young's modulus for the material mild steel, and this value is 2.1 into 10 raised to 11 Newton meter square. That is the units for Young's modulus of a material. And using all these quantities, हमसे पूछा गया है to calculate the force which was applied on this wire. We denote force with the letter capital F. नाउ अगर आप क्वांटिटीज देखो, हमारे पास लेंथ है, हमारे पास डेल्टा एल है, हमारे पास यंग्स मॉड्यूलस है, फोर्स है, एंड इफ यू ट्राई टू रिकॉल ये सारे क्वांटिटीज जब डिस्कशन में होते हैं, वो डिस्कशन में होते हैं व्हेन वी वर डिस्कसिंग यंग्स मॉड्यूलस. तो बाय डेफिनेशन यंग्स मॉड्यूलस इज फोर्स into the original length of the wire divided by the cross sectional area of the wire into the change in the length of the wire, that is delta L. So ये था formula to calculate the Young's modulus. बट यहाँ पर एक चीज़ है, हमें क्रॉस सेक्शनल एरिया यहाँ पर कहीं पे भी गिवन नहीं है, बट नॉट टू वरी बिकॉज हम बात कर रहे हैं वायर के बारे में. तो वायर इज इफेक्टिवली अ सिलेंडर, एंड सिलेंडर में हमारा जो क्रॉस सेक्शनल एरिया होता है, दैट इज ऑलवेज द एरिया ऑफ अ सर्कल, विच वी कैन इजीली कैलकुलेट यूजिंग द फॉर्मूला पाई आर स्क्वायर. सो इसी फॉर्मूला का एक अल्टरनेटिव फॉर्मूला है, मेक श्योर यू कीप दिस इन योर फॉर्मूला बुक, एफ एल, and A की जगह पे हम substitute directly करते हैं the formula to calculate cross sectional area, that is pi r square into delta L. Now if you see, हमारे पास almost सारे quantities available है, but you will be like, sir, the formula uses radius. We have no information about the radius in the given data whatsoever. But not to worry, हमें diameter पता है, and diameter पता हो तो radius ढूंढना कौन सी ही बड़ी बात है. So radius we can easily calculate. So radius of the wire must be diameter divided by 2. So it is 0.60 into 10 raised to minus 3 divided by 2, which gives us 0.30 into 10 raised to minus 3 meters. That is the radius of this particular wire. So value of R is known to us as well. एंड इससे हम इस फॉर्मूले के वर्जन से तो फोर्स नहीं ढूंढ पाएंगे बिकॉज दिस इज द फॉर्मूला फॉर यंग्स मॉडुलस. सो लेट्स ट्राई टू रीअरेंज दिस फॉर्मूला. सो इस फॉर्मूला को इफ आई रीअरेंज इट, सो आई कैन से एफ इज इक्वल टू पाई आर स्क्वायर into delta L into y, the whole divided by the length of the wire. And this shall be our formula which will help us calculate the value for the force. तो हमने क्या किया है, f को आइसोलेट किया है और ये सारे टर्म्स को राइट हैंड साइड पर भेज दिया गया है, सॉरी लेफ्ट हैंड साइड पर भेज दिया गया है. So this is the formula which we will be using to calculate the force. Now if you see, All the values are known to us in our given section. So a simple substitution should get us the value for the force on the wire. So calculation में the first statement we write from formula 2 because that's the formula to calculate the force. I can say force experienced by the wire F must be pi ka value, that is 3.142, into the radius, that is the radius ka value was 0.3 into 10 raised to minus 3 as we calculated, ka whole square into delta L ka value, which is 6.3 into 10 raised to minus 3 as well. So 6.3 into 10 raised to minus 3. So this was the value of delta L into the Young's modulus, which for steel is 2.1 into 10 raised to 11. A lot of values. I hope we can cancel a bunch of values in this. And the whole thing divided by the length. So length was said to be 1.5 meters. So 1.5 there as well. So first thing first, let's try to open all the brackets. So 3.142 into 0.3 into 10 raised to minus 3 ka whole square would be 0.09 into 10 raised to minus 6 into 6.3 into 10 raised to minus 3 into 2.1 into 10 raised to 11, the whole divided by 1.5. So first, I think we should try to simplify it by solving all the 10 raised to terms. So 10 raised to minus 6 into 10 raised to minus 3 gives us 10 raised to minus 9, and into 10 raised to 11 gives us 10 raised to 2 there. So we get 3.142 into 0.09 into 6.3. Make sure you do not lose any of this term. You have to be very very careful. आप सारे के सारे terms जो है jot down करो, या फिर otherwise you'll simply lose marks for silly mistakes. So as we said, 10 raised to minus 6 into 10 raised to minus 3 gives us 10 raised to minus 9, and 10 raised to minus 9 into 10 raised to 11 gives us 10 raised to 2. एंड हम क्या करेंगे, अब इस 10 raised to 2 को 0.09 से मल्टीप्लाई कर देंगे, सो विच विल further give us 3.142 into 9, because 0.09 into 10 raised to 2 is 9, into 6.3 into 2.1, the whole divided by 1.5. Also, what we can do is we can get rid of this 1.5 because 1.5 ones are and 1.5 6 are 9. So we get a simplified version of the term which was very complex to begin with. So 3.142 into 6 into 6.3 into 2.1. Now you can use the logs for this calculations, but I'll suggest you multiply 6 and 2.1 as well, so that आपको एक और term कम होगा to calculate the logs for, because 6 into 2.1 is 12.6 into 6.3. So 6 into 2.1 gives us 12.6. And now you can use logs for calculation. So make sure you use logs for calculation in your exams or in your college. But in the video, we'll skip this step. And अगर आप इन तीनों terms को multiply करोगे, so you get the value of force as 2.494 into 10 raised to 2, which is effectively 249.4, which is roughly 250 newtons. So this is the value of force. We did this to be consistent with the textual answer, but even if, let's say, you present the answer in this exact format, it's valid. So the value of the force experienced by the wire is 250 newtons approximately. The link for the PDF of this solution is available to you in the description, so make sure you check that out. Have a nice day.